let's do an example of how to find uncertainties. Throughout the semester, you're going to have to do this. This is an example of error propagation. It's one thing to figure out what the uncertainty is when you're making a measurement, like a mass. I massed this. I know that the precision of my, okay, I didn't mass this. This is the length. So I use the calipers. And my precision of the calipers is plus or minus 0.1 centimeters, or that's 0.01 centimeters, or 0.0001 meters. And by the way, the calipers is 10 times more precise than a ruler because it can measure to the 0.1 millimeters. A ruler can only measure to the 1 millimeter. So this complicated looking equation is actually not that complicated. This comes from error propagation theory in statistics, and it's when you actually multiplying many things together, you add the errors in quadrature. So I can't go into how this is derived. It requires calculus 3, but if you take MA 331, which is a standard statistics course here that's calculus based, you'll be able to start to understand how some of this works. So what I'm going to do is just show you the formula to find the volume, the error in the volume, uncertainty in the volume. So this thing right here is called, it's a little baby delta. It's a Greek letter. Okay, its name is delta, D-L-T-A. A capital delta is this rectangle. That's the capital delta, and this is the baby, or the lowercase delta. They're Greek letters. And so we use both of them to mean changes in things. So delta is just small changes in something. So this is or uncertainty. So in this case, it's meaning the uncertainty in the volume. So V means volume, the uncertainty of the volume. That's equal to the volume itself. So we calculate the volume times these things in here. So side 1, I just put side 1. So let's put side 1 is equal to this. Let's put S1 is equal to 6.25 centimeters. And S2 is equal to 1.30, and S3 is equal to 1.28 centimeters. Now, what are these delta S's? Those are the uncertainties. So in each one, the uncertainty is going to be equal to this 0.0001. So delta S1 is 0.0001. It's the uncertainty in the measurement of S1. The uncertainty in S2 is 0.0001 meters. The uncertainty in S3 is 0.0001 meters. So that's what these guys are. And it turns out we're using the same device to measure all of these, so we're going to have the same uncertainty. That isn't always the case, but in this case it is. So the first thing you want to do is find the volume, which you should have already calculated. So you're going to put that in V. So to find the volume, what you do is you take 0.0625 times 0.013 times 0.0128. And you should get a small, the volume in square meters. Now, again, what you can do is scientific notation. What I'm going to do is I'm going to do this separately. So V, 1.04 times, and so this is what I come out with, 1, 2, 3, 4, 5, negative fifth meters cubed. So a meter is a very, very, very large thing. So this is not very large. It's a very, very tiny fraction of a whole cubic meter. As a cubic meter is formed by a meter stick on the 3 sides of a cube. So now that we've got V, that's going to be in there, then we just kind of plug everything in and calculate it out. So I'm going to show you where the things go, and you're going to calculate it out yourselves. So S1 is 0.0625 divided by the uncertainty 0.0001. And I'm not putting the units in because there's a meter here and a meter here, they cancel out. This is called adding errors in quadrature. This is the error. You've got the actual divided by the error plus the actual measurement, which is divided by the error. So your second measurement is this one. So all I'm doing is putting S2 is 0.0130 and then the error. So all throughout the semester, you're going to be doing this. When you multiply or divide, you do the same thing. It doesn't matter if you multiply all 4 dimensions or multiply some and divide them. What you do is you just add them underneath the square root sign, multiply by the thing that you're trying to find the uncertainty with. And S3 is 0.0128 divided by 0.0001. Now, it's not so bad. And then what you do is you just multiply that by the volume. So 1.04 times 10 to the minus fifth meters cubed. So again, that's the uncertainty in the volume. So do that all out, and you will get your uncertainty in the volume.